So we will spend just today together on it. Any extra learning you need to do on lesson 2.6, make sure you're studying in your book. And then again, like I said, we will not be going into lesson 2.7. We'll forgo that lesson. We will have a quiz on 2.4 to 2.6 on Thursday. Beginning of next week will be the chapter 2 test. Okay? So some of you have a quiz retake to still take care of on 2.1 to 2.3. And of course, the same thing will hold true for 2.4 to 2.6, you need to get a 75% or higher to be test eligible. So let's talk about compound inequalities. Compound inequalities are two inequalities, so two simple inequalities. That's what we really call the kind we've been working with so far, are just simple inequalities. So if we take two simple inequalities and we join them together with the word and or the word or, so we put two of them together and they either have a relationship of being an and compound inequality or an or compound inequality, and they each mean their own thing. So our compound inequalities are still graphed just like our simple inequalities are, and we're going to graph them on the same number line. In other words, they have a solution together. So we put them on the same number line. We don't graph them separately. So the and compound inequalities are where the values where both inequalities, in other words, you have to find where are those values that make both inequalities true. So both inequalities have to be made true by any value you choose for x or whatever your variable is. Here's an example of a compound and inequality. Now notice what, you don't see the word and in there at all. It doesn't say and, but really what this one says is that x, being in the middle, is greater than, we're reading it from the inside out, x is greater than or equal to -3, and x has to satisfy that other side of it, x is less than 3. So any numbers that would satisfy both of those things for x could be considered a solution of this compound inequality. So let's graph that and see what that would look like. X greater than or equal to -3. Would -3 be shaded in, first of all? Okay, so because the equal to bar is there. Which direction will we shade that part of our compound inequality? That one would be shaded to the right. So let's do like this. Let's show that that one would get shaded like that. Well then, x is less than 3. Would 3 be shaded in? No, because there's no equal to bar in that one. So our endpoint would be an open endpoint this time. X is less than 3. What's that? What direction will we shade? To the left. Okay, so we're going to go like this for this one. And what we're looking for right now is the intersection of, the overlap of those two regions that we would satisfy both of them together. In other words, it comes from either shaded region. So where are those at? So is -3 shaded in both regions? If we shaded this one, is -3 shaded? And this one here, is -3 shaded? Yeah. Is -3 shaded in this one? So is -3 a solution? Okay, let's try it out. -3, let's put it in here. Is -3 greater than or equal to -3? It's not greater than, but it's equal to, right? Is -3 equal to itself? Yeah? So if I put -3 in here, we're just checking that one out right now. It does satisfy going this way. Is -3 less than 3? Yeah, it satisfies that one also. It has to make both of them true. Okay? How about the +3 right here at this endpoint? How about +3? Is that one going to make both of them true? Is 3 greater than -3? Yes. Is 3 less than itself? No. So is 3 a solution? No, because it only makes one of them true. It has to make both of them true. It has to be the intersection of, it has to be the overlap of, it has to make both of them true. So we do not have positive 3 in our solution set. Well, then how are we going to show this? How about, pick a number from over here for me. Negative 5. Okay, let's try negative 5. How about negative 5? Is negative 5 greater than negative 3? No. Is negative 5 greater than negative 3? No. Is negative 5 less than 3 though? Yeah, but it doesn't matter because it has to make both of them true. So negative 5 makes this one true, but it doesn't make this one true. How about a number from over here? Positive 5? Should we go with? How about positive 5? Let's get rid of that negative symbol, and let's just make it a positive 5. Is positive 5 greater than negative 3? Yeah. How about, is positive 5 less than 3? No, so it can't make that one true. So it makes one of them true, but it doesn't make the other one true. It has to make both of them true, so 5 isn't going to count either. So it's kind of looking like right now, we have now eliminated any numbers from here on, and we have now eliminated, starting with positive 3, and any numbers from there on. So let's try out something in the middle, like, how about 0? Let's try 0, see if that one works. So if we have 0, is 0 greater than negative 3? Okay. Is 0 less than 3? Okay, so it makes both of them true. We could keep trying numbers in between here, but what do you think is going to happen? This is the overlap region where they're shaded in between here, both of them. So we're going to shade in between here, and we're going to say anything in between negative 3 and positive 3, including negative 3, that's why it's shaded in, excluding positive 3, it's open, and we decided it can't. So our solution really becomes from negative 3 up to positive 3. Okay, so when we have the and kind, that's called an intersection. Where do they overlap? Where do they share solutions? But then the or kind are the values where, excuse me, I don't know which word I wanted to use here, so we're going to look it up. Where either one or the other. Either of them. It doesn't matter which one, just as long as one of them makes the inequalities true. As long as either of them do. So like in our last one, we had that positive 3. If this was an or compound inequality, it would have been a solution because it made one of them true, even though it didn't make the other. So here's our example this time. We have this, when you have an or one, they write it with the word or. We don't put it together. We have two x's, two variables in it. So x is less than or equal to 2. It can come from that, or it can come from x is greater than or equal to 7. So we'll shade in our 2, and shade which direction? X is less than or equal to 2, to the left. Now notice what I'm not doing here that we typically do in our simple inequalities. We have an endpoint, one endpoint, and then integer neighbors. Here, in compound inequalities, we're going to have 2 endpoints and no integer neighbors involved, okay? So then it doesn't matter how far apart or how close you make them. And then our 7 is included because of the equal to bar in the other part of our compound inequality. And the numbers greater than 7 go to the right. And so now, both ends of this are actually considered solutions. Because our solution only needs to come from one inequality, one part of the inequality or the other. It doesn't have to come from both. This is called a union. Bring them together and just let them all be part of the solution set. Union them together, put them together, add them together, and it doesn't matter where the solution comes from. Typically, now don't hear me wrong in this. Typically, but not always, when you have a compound or inequality, this is how the solution will look. It's going to go out from 2 endpoints. Doesn't mean the endpoints will always be included, but it will go out like this, typically. And ones typically are contained between the 2 endpoints. Okay? Okay, let's practice writing what the compound inequality looks like given the graph instead. So remember, the shaded region represents x, or whatever variable we choose to use. So this is like our x right here. So we would put, is this an and one or an or one, do you think? This is an and one. So do we use the word and? No. We just put the x in the middle, and we work our way out both directions. So if we go this way on the number line to the left, what's true about, we have our endpoint -5 here. So what relationship does x have to -5? Or you could say it the other direction. What relationship does -5 have to the shaded region x? What inequality symbol do you think we could use? So this one?
No, less than or equal to.
Less than or equal to. Okay, so this one. Okay, let's check it out and see. If we read it from the inside out, x is greater than or equal to -5. Are these numbers greater than -5? Okay, and is -5 shaded in? It is, so that's why we're going to have our equal to bar. Okay, how about the other endpoint, which is -3? What relationship does x have, does the shaded region have with that -3? Is less than? How about the equal to part? Why not? Because the endpoint's not shaded in, so we don't want the equal to part in this one. So our compound inequality reads like this. -5 is less than or equal to x is less than -3. Or we could say the word and. -5 is less than or equal to x, and x is less than -3. So here's our compound inequality that represents that graph. Okay, how about number 2? What kind is that? It appears to be an or one. Okay, so we would have our negative. Can we do it like this? Can we put x in the middle this time? No, we do not put x in the middle. This is an and one, and this is not an and one. This shows it from two different regions. So we're going to have our first inequality be as x is what? Less than -4, or x is greater than +4. No equal to parts in either of them? Okay, we have to evaluate them on each of the endpoints. Neither of them are shaded in. So our compound inequality reads this time, x is greater than less than -4, or, and you have to put the word or in there, x is greater than +4. Okay, you do number 3 then. What would it look like? And who wants to come up and offer to write it on the board for us what it looks like? Come on up. You can volunteer. Just wave your finger, it's gonna write red. For bloody Halloween. Okay, come on, somebody up here. Compound inequality being represented by this graph. Time's up. Come on up, Chase Ross. This is your lucky day. You can bring your paper with you. And your finger to write in blood. Aiden, that was totally uncalled.
Sorry.
Thank you. Anybody agree, disagree?
Agree.
You disagree? Okay, what do you want it to be, Avery? Come on up and show us yours. Underneath his. I'll be erasing his because, you know, we had some people who agreed with him and maybe they and him are right, or maybe it's you who's right. Who knows? Okay, thank you. Okay, what do you think? Anybody want to agree with Avery? Disagree?
Okay, so Chase's says x has to be greater than or equal to negative 1. Come on up, let's put it on my desk, turn it off. X is greater than or equal to negative 1. Are these shaded numbers greater than or equal to negative 1? Are these shaded numbers greater than or equal to negative 1? Okay, and according to Avery's, this says, here's what Avery says. Avery says that the shaded region X is less than or equal to negative 1. Aren't those these guys over here? Okay, so far we're going to have to stick with Chase, aren't we? Okay, and then it says, and X has to be less than or equal to 1. So are these numbers less than or equal to 1? This says X is, well, that part of it's right. This part of Avery's compound inequality is right, isn't it? So we are going to go with Chase's, which is this one. We can't have that one, right? Okay, so if you do not have the right one, make sure you have it now. Thank you, Chase. Okay, any questions before we move on to solving them? Okay, then let's do that. Let's go to the back and start solving them. Okay, when solving and ones, okay, solving and inequalities, whatever you do to one region, how many regions do you think an and inequality has? 3, yeah. It has the middle, the left end, and the right end. Whatever you do to one region, you must also do to the remaining 2. So whatever you do to one region to get the variable alone, make sure you do it to all 3 regions, so you got to do it to the other 2 also. So we have a region, and a region. And where do you suppose the X is going to hang out? In the middle, yeah. Okay, so we look in the middle and we say, okay, what do I have to do to get X alone? Subtract 2. Okay, so we'll subtract 2. If we do it there, we have to do it on the left end, we have to do it on the right end. We have 3 regions here. Negative 3, take away 2. Negative 3, take away 2.
Negative 5.
Thank you. Way to redeem yourself, Avery. And is less than. What's in the middle now?
X.
X. And what's
5.
bring is less than, and we have a 5. Do we have anything left to do? No. No. We graph it. Negative 5 is one of our endpoints. Positive 5 is the other. We don't care about integer neighbors in compound inequalities. We'll just worry about our endpoints. Should we have a shaded circle at negative 5 or an unshaded?
Unshaded.
Unshaded. Okay. How about at positive 5?
Unshaded.
Unshaded. Okay, now let's evaluate. X is supposed to be greater than negative 5, and it is supposed to be less than positive 5. Where are those numbers?
In the middle.
In the middle, in between them. In between them. Okay. Number 5, what's going to be our first move? Subtract 1. We have a multi-step. So we're going to subtract 1 from every region. Trust me, you're going to forget about one of the regions sometimes. Leave it out, and then that's going to create an incorrect solution. So now we have 2x in the middle. We bring down our is less than symbol. We bring down our is less than or equal to on the other side. What's negative 3 take away 1?
Negative 4.
Negative 4. Oopsie, I'm down a line. Okay. Negative 4. How about 9 take away 1? 8. Are we done? What do we do next? Divide every region by 2. Divide every region by 2. Even in compound inequalities, we have to take into account, did we multiply or divide by a negative? No, we divided by a positive 2. So we're not going to switch the symbol. So we have negative 2 is less than or equal to x is less than 4. Now notice, the endpoints don't always end up opposites of each other. Don't get tricked into thinking that the other endpoint has to be the opposite of the first one. Are negative 2 and 4 opposites? Oh no, you guys are looking at me like you don't know what I'm talking about.
No, they are.
Okay. Thanks, Tate. I'm going to go with that. You're speaking for the whole group. They all know what opposites are. Okay, do we have a shaded circle at negative 2?
Yes.
Yes, because the equal to bar is there. Do we have a shaded circle at 4?
I know.
No. And then we say, what numbers satisfy both? X is greater than -2, which is to the right. X is less than 4, which is to the left, so the intersection of them will be in between, what we said would typically happen. But we always want to make sure that that's what happens, okay? So when we're solving compound and inequalities, whatever you do to one region, make sure you do to all parts, all regions. Any questions on that one? Okay, then let's do the OR ones. When you're solving OR inequalities, solve each independent of the other. In other words, separate, whatever word you want to use for independent. Whatever you do to one is not what you're going to necessarily do to the other, because you're solving them independent of each other. So our first, the only one we're going to do here, let's just deal with this one first. What should be our first move?
Subtract 2.
Subtract 2. Now notice, we're just back down to 2 regions here. This is a simple inequality that is a part of a compound inequality. So now we have 3x by itself is less than or equal to what? -9. Okay? What's our next move?
Divide by 3.
Divide both sides by 3. We're dividing into a negative over there, but are we dividing by a negative? No, so we do not need to reverse the symbol. It's going to be x is less than or equal to what? What's -9 divided by 3? -3. So there's one of our parts, but now bring down that word or. Don't forget it. And then you have the other one to solve, which is, what are we going to do?
Subtract 4.
Subtract 4. So we have x by itself already is greater than or equal to 0. And 0 is legitimate, right? So we have, and I shouldn't have circled this quite yet because we really need the circle to be around the whole thing. We have a compound inequality solution also. So our compound inequality solution is x is less than or equal to -3, or x can be greater than or equal to 0. So let's graph that. -3, 0. But pay really close attention, you guys. Here's what else could possibly happen to you when you're solving these. They don't always put in the order in the compound inequality. They don't always do it so the endpoint for this one is going to be the first on the number line, and the endpoint for the other one is going to be on the right. You have to pay attention to which one belongs where. Does -3 come before 0 on the number line, or does 0 come before -3? So don't be fooled by just because this is the first one you solve, its endpoint automatically is the first endpoint, okay? So do we shade in our circle at -3?
Yes.
Yes, okay. Which direction do we shade that one?
Left.
To the left. This is the OR one. It can come from either. And the other one, do we shade in 0? Yes, we do, because it has the equal to bar. Where do we shade? To the right. Okay. Now remember, it's a union of them. So our solution can come from this region or it can come from that region. Okay, any questions on the OR ones? No.